welcome to my channel. Here we are going to be working on this problem, and we have question A, question B, and question C to answer here. So question A says that construct a diagonal scale of 5 centimeters to 1 meter to read a maximum of 5 meters and a minimum of 1 centimeter. That is question A. Question B now says that label the scale constructed in A and indicate a length of 2 meters 65 centimeters. And question C, Roman figure 1, says that use the scale to construct a hexagon of 2.65 meters across corners. And Roman figure 2 of question C says that measure the side of the hexagon. Alright, so these are the questions that we are going to be working on a bit. We have to start with question A, so that whatever we do here in question A, we are going to use to answer question B and question C together. Alright, so question A, as we have here that we have to construct a scale of 5 centimeters to 1 meter. So it means that we are using 5 centimeters to represent 1 meter. And then we need to determine the length of scale. As we have here that the maximum reading that we have to have on the scale is 5 meters. So for every 1 meter, we are representing it with 5 centimeters. So what does that imply? So length of scale is 5 centimeters times 5. Okay, so if 5 centimeters is representing 1 meter, so the length of scale will now be 5 centimeters times 5, so which will give us 25 centimeters. That is the length of scale. Okay, so that's the first thing that we are going to make use of. So let's start and see how this construction can be done. So the first thing that we are going to do is to draw a horizontal line. So we have this horizontal line here. So we have the horizontal line like this. Okay, so on this horizontal line, so I'm going to draw a vertical line. Just move away a bit and draw a vertical line around here. So we have a vertical line here. So we need this space on this side. So we draw this vertical line. And on this horizontal line, so I'm going to take a measurement of 25 centimeters. So I'm going to make use of this set square to take the measurement. So this is 10 centimeters. That is 100. That is 100. So but we are using centimeters in this case as the length of scale is 25 centimeters. So and from this point we also have another 10 centimeters. So that's 20 centimeters. Then I will now take a measurement of 5 centimeters in addition to these 20 centimeters that I've taken. So this is 5 centimeters here. So I need to extend this line. So we extend the line. So the total length here now is 25 centimeters, which is the length of scale. As I've said that we are using 5 centimeters to represent 1 meter, and we are told that the maximum reading should be 5 meters. So which means that if we are representing each meter by 5 centimeters, then the length of scale will be 5 times 5 centimeters, which is equal to 25 centimeters. So that's what we have here. Okay, so what we are going to do now, we are going to divide these 25 centimeters into 5 equal parts so that each of the division will represent 1 meter. Each of the divisions will represent 1 meter. So we take a measurement of 5 centimeters from here. As I said that we are dividing this into 5 equal parts. So this is 5 centimeters, this is 1, and this is 2. So we have it here. Then here we have what? We have the third division. So this is 3, and here this is 4. So the rest here is the 5th one. So what we are going to do now is that we are going to erect a perpendicular line on each of these points. But before that, so we are going to make this a rectangle, and for the width of the rectangle, just take a measurement of 3 centimeters or 4 centimeters. Okay, so just take it like that. So I'm going to take a measurement of 4 centimeters here. So I'll be using 4 centimeters for the width of the rectangle of the for us to construct the scale. So at this point here, I'm going to draw a horizontal line. So I'll draw a horizontal line from here to this end. Okay, so we have formed the rectangle as you can see here, and on each of these points I'm going to erect a vertical line on each of these points. So I'm going to erect a vertical line on each of these points. So I will be making it a thick line. So I'm making it a thick line on each of these points. So we draw a vertical line here, and then coming to this point, so I'll also draw a vertical line at this point. Okay, so we have this. Then at this point I will also draw a vertical line at this point. Okay, then coming to this point, so we also draw a vertical line here. Okay, so now we are going to number each of the points, but the first one that we have here, we are going to make it 0. Okay, then you write 1 here, so this is 2. Okay, so then this is 3, and then here we have what we have 4 here. All right, so this is how we are to number it. This is how we are to number it. The first division, you put 0 there, and you number the rest as I've done it here. All right, so each of these divisions that we have here so represent 1 meter. Okay, as we are told that we are using 5 centimeters to represent 1 meter. So each of these represent 1 meter. Okay, now the next thing that we are going to do is that we are going to divide this, okay, into 10 equal parts. Okay, because the highest unit is meters. Okay, then before meters we have decimeters, and then before decimeters we have centimeters. Okay, so just look at what I'm going to do here. So what we are going to do here is that we are going to divide this 1 meter, we are going to divide it into 10 equal parts, because 10 decimeters is equal to 1 meter. 10 decimeters equals 1 meter. Okay, so we are going to divide this 1 meter that we have here, we divide into 10 equal parts. We divide into 10 equal parts. Don't forget that we have 5 centimeters here, and this 5 centimeters represent 1 meter. Okay, so this 1 meter that we have here now, we are going to divide into 10 equal parts. So if we divide 50 millimeters by 10, so that will give us 5 millimeters each. So this is 5, so this is 2, and then we have 3 here, this is 4, this is 5, this is 6, this is 7, okay, here is 8, and here we have 9, and this is 10. Okay, because we are constructing a diagonal scale, so we also need to come and do the same thing up here by dividing this into 10 equal parts. So because we are constructing a diagonal scale, so this is 1, so this is 2, 3, this is 4, 5, and this is 6, 7, 8, and 9, and then we have 10. So this is a diagonal scale. So what we are going to do now is that you connect this point 1 up here. Okay, this is 0, so this point 1 here, join it with 0 here, so that makes it a diagonal scale. So we draw a line from here to here. Okay, so and I will now connect these 2 with this one here, so you connect this together like this. Okay, so and then so we come to this point, so we connect these 2 points together, so it has to bend, so like a diagonal on a rectangle. Okay, then we also connect these 2 points together like this. Okay, so we have this, and then we connect these 2 points, we connect them together as we have here, and then these 2 points, so we connect them together, and then these 2 points, so we also connect them together like this. So connect these 2 points together, and lastly, so we connect this point together with this point. Okay, so look at what we have. Okay, so this is what makes it a diagonal scale. All right, so the next thing that we are going to do is that, so we now need to create that of the centimeters part. So this part that we have here is for meters, while this one that we have here is for decimeters. Now we want to create that of centimeters now. So that's going to be created here, as we know that 10 centimeters is equal to 1 decimeter. 10 centimeters equal to 1 decimeter. So what we have here, though we took 40 millimeters or 4 centimeters, so we are going to divide it into 10 equal parts so that we can have centimeters on this part. So I'm going to divide, so 40 millimeters by 10 will give us 4. So I'm going to take a measurement of 4 millimeters each. So this is 4. Then after that, I'm going to have 8. So this is 8 here. Then after 8, I have 12. So this is 12. Then after that, I have 16. So after 16, I have 20. After 20, 24. After 24, I have 28. So after 28, I have 32. Then after 32, I have 36. So this is 36. All right, so we have divided into into 10 equal parts. So the next thing that we are going to do is that we are going to draw a horizontal line through each of these points. So through each of these points, we draw a horizontal line. So we take a horizontal line from this point to this end here. Okay, so and then from this point, we also draw a horizontal line to this end. Okay, so then we come to this point. We also draw a horizontal line from here to this end here, and we do the same thing for this. Draw a horizontal line from here to end, and then here we draw a horizontal line from here to the end here, and then we also draw a horizontal line here, so from here to the end. Okay, so we go on. So we draw a horizontal line. So from here. Okay, and then next, so we have this, we draw a horizontal line from here. Okay, and then so coming up here, so we also draw a horizontal line from here to the end. Alright, so we have the centimeters part here. Okay, alright, so I'm going to make this line. So I'm going to make this line, I'm going to make it a thick line. So because this is the major length or scale that we are given. Okay, so we have it like this. Alright, so then if I'm numbering this one now, so this is 0, this is 1 and 2, so I will put 2 here. Then 3, 4, I will put 4 at this point, and then 5, 6, I will put 6 here, and 7, 8, I will put 8 at this point, and this is 10. Okay, so on this also, so this is 1 and this will be 2. I'm going to put 2 here, 3, 4, so I'll put 4 here, and 5, 6, I'll put 6 here, 7, 8, I'll put 8 here, and then so we have 10 here. Alright, so next thing that I'm going to do, I have to write the unit on this scale. Okay, so I'm going to write meter here, so and then here we have decimeter and here we have centimeter. So I will do that while I pause video, and when I'm done you will see what I've done. Alright, so here I've written the unit. So here we have meters, so this is decimeters, so why we have centimeters here. Now let's answer question B. We have answered question A by constructing this diagonal scale. Now question B now says we are to label the scale constructed, and then we are to indicate a length of 2 meters 65 meters. So we have labeled the scale. So what we have to do now is to indicate a length of 2 meters 65 centimeters. Alright, it's very simple. So this is 2 meters here. So where we have these 2, as I said that each of these represents a meter. Okay, so this is 2 meters here. Now, so we now go for us to look for 65 centimeters. 65 centimeters. So that's going to include these decimeters. Okay, so we are going to count from here. So 6, 1, 2, 3, 4, 5, 6. So when you get on this 6, you now go up on centimeters to count 5. Okay, so we have 1, 2, 3, 4, 5. Okay, so this is where we have 5. So we are going to take note of this point. So I'm going to take note of this point. So by shading this, okay, just put a visible dot on this. Okay, so what I'm going to do now also on this shoe, by following this line, so I will also take note of this point. So take note of this point as we have it here. So now, so I'm going to make this line, I will make it a more visible line, so a thick line. Okay, so that's what I'm going to do now. So to show the distance of 2 meters 65 centimeters on this scale. Okay, so this is what we have here now. Okay, so that is the distance. Then I'm going to write it on it. So this is 2 meters, so 2 meters, so 65. okay, 65 centimeters. So we have to write it here. So we have indicated that distance or that length as we are told. All right, so we have answered question A and question B. So question A is for us to construct the scale, while question B is for us to label the scale, which we have done. So meters here, decimeters here, and centimeters here. And then part of the question B is for us to indicate a distance or a length of 2 meters 65 centimeters, which I have done here. Now let's move to question C that says that we are to use the scale to construct a hexagon of 2.65 meters across corners. Okay, so distance across corners is given as 2.65 meters. So what we are to do now is for us to so we are going to draw a horizontal line. So we are going to draw a horizontal line here. So we draw a horizontal line. So this is the horizontal line as we have it here. So the next thing that I'm going to do is that I'm going to take this distance. So I'm going to take this distance so that we can transfer this distance. We transfer it here. So because that's going to be the distance across corners that we are given. So I will take this distance. Okay. So from here. Alright, so I'll take this distance. So this is distance 2.65 meters. So here I'm going to put it somewhere here. Okay, then I will make an arc on the line. Okay, so then bringing it back here to this point. Okay, then I will also make an arc here. So this is I've transferred this distance from here. I've transferred it here. So the next thing that I'm going to do is that before we can construct the hexagon, we are going to bisect this distance. So this distance we are going to bisect it. Let's call it. So this is distance AB or length AB. So that is the distance across corners of the hexagon. So I'm going to bisect it. So by putting the pinpoint of my compass here, extend the pen point of the compass. I will extend like this, and I will draw an arc up here. So draw an arc down here, and I will bring it to this point, or to point B here. So I will also draw an arc up, and I will take it also down. So we have this. Okay, the next thing that I'm going to do is that I'm going to draw a line. So through this point, that is bisector of the of length AB. So I will draw this line, so like this. So we have bisected the line. Next thing that I'm going to do is that, so if this is the center, so I will call this point O here. So I'm going to put the pinpoint of the compass at this point O here, extend to B or extend to A, so which is the radius of the circle that will give us this hexagon. So I'm going to draw a circle all around like this. So draw a circle. Okay, so I'll draw a circle like this. Okay, so the circle goes as we have it here like this. Okay, so the next thing that I'm going to do is that the radius that we used to draw this circle, I'll put at this point here, point A here. I'll make an arc up and down here. Okay, so we have this, and I'll also put it at this point, and then I'll make an arc up and down. Okay, so we have this point. So this is, so I'll call this point, so this is point C. Okay, okay, so this is point D on the circle, and this is point E, and then here we have point F here. Okay, so then we form the hexagon now by joining the point together. So we join this point A and D together. So join point A, D together, and then we join point CD or point C and D together like this. Okay, so then we join point B and C together. So it goes like this. Then point ABF. So we join this together. Okay, so then we join EF together. Join point E and F together. So there is another side of the hexagon, and then we join point AE together. So we have this. So we have formed the hexagon as you see here, whose distance across corners equal to 2.65 meters. Now we are asked to measure state the length of the hexagon. So if I take a measurement of this now, okay, so this is this distance that we have here is 6.65 7 centimeters. So 6.7 centimeters. So 6.7 centimeters. Okay, so that's what we have here. Now we have to convert it to meters. Okay, so as we know in the question that we have that 5 centimeters, so 5 centimeters as given in the question is equal to 1 meter, so is equal to 1 meter. Then we now have that 6.7 centimeters, okay, so is equal to how many meters? So let's find out that. So I'm going to make use of calculator, though that's going to be 1 point something, but I'll quickly use calculator to determine that answer. So that means we are going to divide this 6.7 centimeters by 5 if we cross multiply. Okay, so you know how to work that out. So we have 6.7, so divided by 6.7 divided by 5, and that gives us 1.34. So 1.34, so this is equal to 1.34. So 34, so 1.34 meters. Okay, so that is the length of the hexagon. So converting it to meters, as simple as I've done it here, all you have to do is to practice, and when you practice this, become a master at this work. Thank you, keep on practicing, and God bless you.